In this video, an axial flux motor has a yokeless stator in between two rotors. The acid structure is being analyzed using the magnetostatic analysis option of MotorXP-AFM. Depending on the simulation setup and required accuracy, the simulations range from several seconds to several minutes.
Let's start with entering geometry parameters. There are several options for the motor topology, single-sided and double-sided with rotor or stator in the middle. There are two stator geometries available by default with flat and round slots. Custom stator geometries can also be added. The Guide button opens a user guide with all the dimensions shown. Open the stator editor to enter dimensions of the slot. Open the rotor editor to enter dimensions of the magnet. There are several default magnet configurations available. You can also add your own custom rotor geometries. Magnet segmentation helps to reduce the eddy current losses in the magnet. For this example, we will use 4 magnet segments. The geometry is ready. Materials for each part of the motor can be selected on the right. Properties of each material can be viewed by clicking the corresponding button. Custom materials can also be added to the materials library for each group of materials. Let's proceed by entering the parameters of the winding. The winding layout is automatically calculated after the number of slots and pole pairs are entered. The fundamental winding factor and harmonic winding factors are automatically calculated. The winding is ready. Next, navigate to the Mesh Editor tab. The 3D view of the mesh allows for a better understanding of the principle of the quasi-3D finite element analysis when the magnetic field is simultaneously solved in several cylindrical and radial cross-sections. For the initial analysis, let's select one cylindrical mesh slice, which will provide the fastest simulation speed. The more cylindrical slices used, the higher accuracy, but low simulation speed. After entering the current and mechanical speed values, the model is ready for the simulation. Single-point simulation setup allows the fastest analysis. As you can see, with the single simulation setup and one cylindrical mesh slice, the analysis takes only 15 seconds. For a more comprehensive analysis, let's increase the number of cylindrical mesh slices. In order to make changes to the mesh, the file needs to be unlocked first. Three mesh slices provide sufficient accuracy in most cases. Multiple points simulation setup provide better accuracy compared to the single point simulation setup, as the results are based on magnetic field solutions for similar rotor positions. Selecting the Save Each Step Solution checkbox will allow the use of animations. As can be seen, the simulation with 72 rotor positions and 3 cylindrical mesh slices takes much longer compared to the previous example, but provides much more accurate results, with iron and magnet losses also taken into account. Besides general simulation results, machine constants and flux density levels in different machine parts are also available. Some examples of waveform plots versus time. And air gap distribution plots as well for tangential and normal flux density components. Animation of the flux density distribution in the middle cylindrical cross-section of the motor. And one more example of the cross-section distribution plot for the iron loss density.